Hello and welcome to the Neutralizer's neutralization video. Today we are going to talk about neutralization from the acids and bases topic. To start off, an acid is any compound that increases the amount of hydrogen ion, H+, in an aqueous solution. The opposite of that is a base, which is defined as a compound that increases the amount of hydroxide ion, OH-, in an aqueous solution. Basically, the acid loses its hydrogen and the base takes or gains hydrogen. The reaction of an acid and base is called a neutralization reaction. In fact, the general reaction between an acid and base is acid plus base, producing water plus salt, with salt being the ionic compound. Now, written on the board here is some of the things that you should know when it comes to neutralization. Water is neutral when it comes to acids and bases. H2O will always be a product in a neutralization reaction since the acid will contain H+ and the base will contain OH-. Acids will form H3O+ and bases form OH-. What is always soluble is K+, Na+, NO3-, and NH4+. Also shown is the list of strong acids and strong bases, with that equation above being the leading equation for neutralization. In that, OH- takes H from H3O+, and forms an H2O in this equation to balance it. But since the reactants have 4 H's and 2 O's, it'll form two H2O's in the products. Here we have H3O plus OH- as our reactants. Remember, OH- will take an H from H3O+, creating H2O plus H2O as our products. Our second practice problem, KOH plus HNO3. As mentioned before, H2O will always be a product. Therefore, the product will be H2O plus KNO3. K goes before NO3 because it is a metal, and metals always go before non-metals. Here we have our third practice problem, including CaOH2 plus HCl. To make this problem easier, it's best to work it out by breaking the compound down. As shown here, CaOH2 will be broken down to Ca, OH, and OH, and HCl will be broken down to H and Cl. One OH- will take the H, but since there is one left, we need to add an H. Multiplying the compound by 2 will result in 2 hydrogens and 2 chlorides. Since both OHs have taken 2 hydrogens, it would create 2 H2Os, leaving Ca and 2 chlorides. According to the periodic table, calcium had a charge of 2-, so next we would have to do the whoop-whoop method, resulting in CaCl2. And remember, Ca is a metal, which is why it goes first. We have our fourth practice problem, including H3PO4 plus SrOH2. To make it easier, you would break down the compounds. For H3PO4, it'll be broken down into 3 hydrogens and PO4. For SrOH2, it'll be broken down into Sr, OH, and OH. Since there are 3 hydrogens, the charge will be 3+, because each hydrogen is 1+. Therefore, PO4 will have a charge of 3- in order to make the compound neutral. There are only 3 hydrogens and 2 OHs, so you have to find a common multiple, 6. So multiply the H3PO4 by 2 and SrOH2 by 3. As a result, there will be 6 H2Os, and for PO4 and Sr, you would have to use the whoop-whoop method. According to the periodic table, Sr has a charge of 2+, and we already concluded that PO4 has a charge of 3-. Once you are done with that step, the final product will be 6 H2O plus Sr3, PO4, 2. The PO4 has a 2 at the end due to multiplying H3PO4 by 2. Finally, we have our last practice problem, number 5. This problem is a little different. Here we're going to be drawing. What we're going to draw first is HCl plus NaOH and water in the reactant side. When drawing it, the compound should be broken down. Shown in the reactant side is H+, Cl-, OH-, and Na+. And H2O will also be in the reactant side since the reaction is happening in water. Before figuring out the products, what I recommend is to set up the problem as you would in any neutralization reaction. In the problem, the OH will take the H from the Cl and will create an H2O, leaving NaCl together. Again, remember the metal goes first. We'll break down those products to draw them in the product side. By the way, there can be as many water molecules, H2O, because the reaction is happening in water. We have reached the end of our video. Here we have some important reminders. Water will always be a product in a neutralization reaction. Water is neutral. Acids lose hydrogens and bases gain hydrogens. Come back for more neutralization reactions from the neutralizers. Periodic.